today we are going to learn about derivative of ln x, logarithmic function with base e. Before I start, I want to review some stuff related to logarithms. First thing I want to review, if we have ln k equal m, this can be written in exponential form as e to the power of m equals k. Log or ln e equals 1 and log of n base n is 1 because the base is e, so e to the power of what equals e, so e to the power of 1 equals e. For ln or log, x has to be greater than 0. The graph of this function looks like this. It has a vertical asymptote, which is the y-axis. So x can never be 0 or less. X has to be greater than 0, the domain. Another thing I want out, log or ln of 1 equal 0, because if I want to find ln of 1, that means e to the power of what equals 1, and of course e to the power of 0. The same thing with log. Okay, so those are some stuff I want you to remember when we work with finding the derivative of ln and log, because these rules will simplify things as we go. Some rules I want to go over, and those rules are valid for natural log ln and log with any other base. Of course, if I don't write a base, that means the base is 10. So here, this is the same thing as the base is 10. This is called the common base. Okay, so now I'm going to do some review for the laws. One, product. If I have ln m times n, this is the same thing as ln m plus ln n. The second thing is quotient. Ln m divided by n is the same thing as ln m minus ln n. There is a power rule that says if I have log or ln, all these laws applies also in log, but I am going to find the derivative of natural log today. So ln x to the power of b, we send the b to the front here, multiplied with ln x. The last thing, if I have log x base b, I can change the base to any other base I want and divide by log the old base to the new base. So those are the four laws that we need to put in our mind while we are working with natural log and log. now we are going to learn about derivatives of natural log functions ln. Okay, one thing we need to remember, if I have f of x equal x squared plus 3x plus 5, this same function can be written instead of in function notation. I can write it in xy notation, y equal x squared plus 3x plus 5. That means y is the same thing as f of x and will be treated the same way we treat f of x when we find the derivative. So when we find the derivative of f of x to the power of n, this is, we use chain rule, which is n f of x to the power of n minus 1 times f prime of x. Same thing we do when we find the derivative of y. So y to the power of n, the derivative of y will be n, y to the power of n minus 1. We are not done. We have to multiply this by the derivative of y, or y prime, or we can write it dy by dx or y prime. Both of them are the same, but we don't forget, or y prime, both are okay. But don't forget, it is not like x. Like, for example, if I want to find the derivative of x to the power of 5, that's 5x to the power of 4. But if I want to find the derivative of y to the power of 5, this will be 5. Oh, sorry, that's derivative. If I want to find the derivative of y to the power of 5, this will be 5y to the power of 4. We are not done. I have to put y prime after that. Okay, so this is another thing I want you to remember. Now, how many minutes? We still have about. Now let us try to find a rule for the derivative of ln x. Let's say y equal ln x. And I want to find the derivative of this. I want to find the formula for the derivative of y equal ln x. We can rewrite this in exponential form. Base exponent result. So e to the power of y equal x. I switched from natural log to exponential form. Okay, now let us try to find the derivative of both sides. Derivative of e to the power of y is e to the power of y times the derivative of the function on the top, f prime, which is y prime here. So this would be dy by dx or y prime. The derivative of y is dy by dx or y prime. The derivative of x is 1. So I can say that dy by dx, I will isolate dy by dx, so I will divide both sides by e to the power of y, so that's 1 over e to the power of y. Okay, 1 over e to the power of y. Okay, now what is e to the power of y? Go back here. E to the power of y is 1 over x. So we can say that dy by dx equals 1 over x. So if f of x equal ln x, f prime of x, the derivative of ln x is 1 over x. This is the rule we use here. Now, let us say I have f of x equal ln g of x. In this case, f prime of x would equal 1 over this have to multiply with the derivative of g prime of x. Chain rule, because this is a composite function. Okay, so we have to apply the chain rule in here. Okay, this is the two rules, and we are going to apply them now with some examples. Okay. So example 1, find the derivative, find dy by dx, y equal ln 5x. Okay, so what we're going to do, the derivative of y, we can say y prime, equal the derivative of ln 5x, ln g of x, so 1 over g of x, 1 over 5x, times the derivative of g of x, the derivative of 5x is 5. Now this 5 and this 5 can cancel out, and that will leave 1 over x. Okay, this is example 1. Let's do another one. Example 2. How many minutes? Oh, I'm running out of time. Example 2. Y equal ln x over x cubed. So if I want to find the derivative of this, I will use quotient rule, because this is a quotient. So y prime will equal low squared, so this will be to the power of 6, low d high minus high d low, the derivative of this 3x squared. This x and this cancels out and leaves squared here, so y prime will equal, I'll factor x squared out, so that's x squared, and this is 1 minus ln 3 ln x. I factored x squared out, so that leaves 1, and I factored from here, so that leaves 3 ln x over x to the power of 6. Of course, this can be cancelled out, and 1 minus 3 ln x over x to the power of 4. This is the derivative. Okay, I don't know. Alright, so we'll continue in a second video. Have a great day. Until now, I see you soon.